Okay, I want you to imagine an AI that can write a news article, or translate a language, or even write computer code for you. Now, this isn't science fiction anymore. It's really happening right now. And it's all powered by this incredible concept called the transformer. So let's dive in and see how this thing actually works. Just take a look at this for a second. It's the start of a news article about, of all things, unicorns being discovered in the Andes Mountains. And they can speak English. I mean, pretty creative, right? Well, get this. This was written entirely by an AI. No human touched it, and it learned how to do this just by predicting the next word in a sentence over and over and over again.
So that leads to the big question, right? How is that even possible? How can a machine do these things that, for the longest time, we thought were uniquely human? Well, the answer lies in a pretty groundbreaking AI architecture.
So it all kicked off back in 2017 with this one research paper called Attention is All You Need. This paper introduced what we now call the transformer architecture, and it is the engine behind pretty much all the cutting-edge AI we see today. You see, before transformers, models really struggled to keep track of context, especially in long sentences. But the transformer's big breakthrough was a mechanism called attention, which let it weigh the importance of different words, no matter how far apart they were. This, right here, completely changed the game for understanding and generating human-like language.
But, not all transformers are created equal. You can kind of think of them as having a few different flavors. On one side, you've got models like BERT. These use what's called an encoder. They are absolute masters of understanding context. Perfect for jobs like figuring out if a movie review is positive or negative. Then on the other side, you've got models like GPT, which use a decoder. And these are the master generators. They're brilliant at writing new text, just like that wild unicorn story we just saw.
All right, so that's the high-level theory. But to really get it, let's walk through a real-world example. We're going to teach a transformer model to do something incredibly human. Recognize emotions just from a piece of text.
Now, I know posing the question like this feels a little dramatic. We're not actually teaching a computer to feel, of course. But what we are doing is teaching it to recognize the patterns in language that we humans associate with feelings. So how do we pull that off?
Step one is always data. And I mean a massive amount of it. In this case, we can use a dataset that has thousands of tweets, and every single one has already been labeled by a person with an emotion, like joy or sadness or anger. The AI needs all these examples to start seeing the patterns for itself.
Okay, so a computer can't just read raw text like we do. We have to break it down into a format it can actually understand. This process is called tokenization. Really, all it is chopping up a sentence into bite-sized numerical pieces, we call them tokens, that the model can work with. It's basically how the AI eats language.
Now this slide here shows something totally fascinating that happens during training. This visual is showing the model's internal brain, you could say, its hidden states, after it's gone through all that data. And you can see the AI has learned to group similar ideas together. See how joy and love are clustered really close, while sadness, anger, and fear are all off in their own neighborhood? It's literally creating its own internal map of human emotion, just from analyzing text.
So you're probably thinking, wow, this sounds incredibly complicated and super expensive, right? Something only giant tech companies can pull off. And honestly, it used to be. But that's where the heroes of our story come in, the open source community, and specifically a company called Hugging Face.
Hugging Face has basically become the central hub for all things AI, kind of like an app store for AI models. They provide the tools, the data, and, most importantly, thousands of pre-trained models that anyone, and I mean anyone, can download and use. This has totally democratized access to technology that was once unbelievably expensive and complex.
Their whole ecosystem just simplifies the entire process. They've got a datasets library to easily grab data, tokenizers to get it ready, transformers to download the pre-trained models, and even a library called Accelerate to make the training part way faster on your own computer. It's like every piece of the puzzle is just handed to you.
So we've talked a whole lot about text, but the truly exciting part, the part that's happening right now, is that this technology is expanding way beyond the written word. Transformers are becoming what's called multimodal, which just means they can understand and work with different types of data at the same time, just like we do.
For starters, transformers can now see. There's a model called the Vision Transformer, or VIT, and it can look at an image like this one and classify it with incredible accuracy. In this case, it doesn't just say dog, it correctly identifies it as an Eskimo dog husky. That's pretty specific. And they can also understand the language of programming. So look here, a simple comment, written in plain English, is given as a prompt.
And boom, the AI generates the exact functional Python code needed to do that. It's essentially translating human intent directly into machine language.
And it really doesn't stop there. The same core idea, the same architecture, is being used to understand spoken language, to analyze video, and even to find patterns in boring old data tables. The Transformer is proving to be this amazingly flexible tool for making sense of almost any kind of information you throw at it.
So what does all this mean? Where does this leave us? We built a technology that lets machines perceive our world in a way that's starting to look a lot like our own senses. It's not just about text anymore. And that leaves us with one final, fascinating question. When an AI can understand our world through text, images, and sound, what problems are we going to ask it to solve next?